For problem 657, Bharat and Ingrid leave their building at the same time on their bikes and travel in opposite directions. So here's a drawing, here's their building, and Bharat and Ingrid are leaving at the same time but in opposite directions. If Bharat's speed is 12 kilometers per hour and Ingrid's speed is 14 kilometers per hour, how long will it take until they are 78 kilometers apart? So part A, if Bharat rides a distance of b kilometers, write an expression to represent how far Ingrid rides. So there's a couple things we can pull from here. The first thing is for word problems, I always like to do a drawing. Helps me visualize the information. And so we know that the distance between Bharat and Ingrid is going to be 78. Because that's how long, we want to know how long will it take until they're 78 kilometers apart. So we want to know how long it will take them to travel this distance. We don't know how far Bharat's traveled. We don't know how far Ingrid's traveled. But from the passage, we do know that Bharat plus Ingrid will equal 78 kilometers. So from the passage, we also know that Bharat rides a distance of b kilometers. So this distance is b. We don't know, but we're given it a value with the variable b. And we know that Bharat plus Ingrid equals 78. Bharat equals b. Ingrid's distance is going to be the total minus whatever Bharat has written, which is b. So we could find that by Bharat plus Ingrid equals 78. And if we put the variables in there, Bharat's distance is b. We don't know Ingrid's, but we do know that together they equal 78. So we're going to solve for Ingrid's distance by subtracting b from both sides. And here we get Ingrid's distance. So Ingrid travels a distance of 78 minus b. So for part A, it asks us to write an expression to represent how far Ingrid rides. Well, this is the equation, I equals 78 minus b. So the expression, 78 minus b, is an expression that represents how far Ingrid rides. For part B, we need to write two equations, then solve the system using the substitution method. So the two pieces of information we have Bharat's, his speed per hour, and Ingrid's speed per hour. So we can set this up as a system, and our two equations are going to be Bharat's equation and Ingrid's equation. And we're going to set it up as distance equals rate multiplied by time. And we know that Bharat's rides a distance of b kilometers, so we're going to let distance d in this formula equal b to represent Bharat's distance. So Bharat's distance equals b, so if it equals b, we're going to plug it in for d into the formula. D equals RT, D equals rate multiplied by time. So we have B equals, that's Bharat's distance, equals rate multiplied by time. So for Bharat, his distance is represented by B. B equals the rate. We know Bharat's rate is 12 kilometers. So Bharat's equation is going to be B equals 12t. For Ingrid, we found Ingrid's distance in the previous problem, and the expression for her distance was 78 minus Bharat's distance. So for D, we're going to plug in 78 minus B, because that was Ingrid's distance. In the rate, here's the rate for Ingrid, is 14 kilometers. So we have 14 kilometers, and there now we have Ingrid's equation. So we can set this up as a system. Here we have Barot's equation and Ingrid's. And we're going to use the substitution method because we have this into b equals form. In previous problems we've had it in y equals, but it doesn't matter the variable. We have b equals 12t. Well, here's b. We're going to do 78 minus b. Well, what does b equal? B equals 12t. So we're going to plug it in to Ingrid's equation. And so instead of b, we're going to have 12t. And always put it in parentheses, your variable, because you're plugging it in for b. And so it's minus whatever b is. And b is 12t, so it's minus 12t. And now we're going to go ahead and solve for t. So here we have minus 12t. Inverse property of subtraction is addition. Creates a zero pair. What you do to one side, you do to the other. So now we have 14t plus 12t equals 26t. Inverse property of multiplication is division. We divide both sides by 26. Creates the giant 1. What you do to one side, you do to the other. So we have 78 divided by 26, which equals 3. So t equals 3. And remember, t represents time. So it will take 3 hours for them to be 70 kilometers apart. If it was asking for the distance, you could plug the time back into either of these equations to get Barot or Ingrid's. So if you needed Barot's distance, you would plug it in for t. 12 times t equals 3, is 36. So it would, in 3 hours, Barot would be 36 miles from the building. And to find Ingrid's, you could either plug it back in here, or if you know that they did 78 kilometers altogether, you could just do 78 minus 36. Problem 658 is x equal 1 and y equals 6, 1 comma 6, a solution to this system. Well, in order to do that, you can plug in the values for your solution. If this solution is correct, if we plug it into both equations, they should both hold true. And you should do this for any time you solve a system of equations. Always plug your solution back into both equations, and if they both are true, then that's the correct solution. So we're going to go ahead and plug x equals 1 and y equals 6 into the first equation. So here's our x and y values, and for the first equation, x equals 1 and y equals 6. When we simplify this, 4 multiplied by 1 is 4, 3 multiplied by 16 is 18, so 4 plus 18 equals 22, and 22 does equal 22, so this is a true statement. So it works for the first equation. Now we need to make sure that it works for the second equation as well. So here's the second equation, and x equals 1 and y equals 2. And always put your values in parentheses, because y equals 6. Put it in parentheses, and we're going to multiply. So first we need to multiply, because we need to follow order of operations. We can't subtract. GEMDAS tells us to do grouping, exponents, then multiplication and division from left to right. So negative 2 multiplied by positive 6 equals negative 12. 1 minus 12 equals negative 11. Negative 11 does not equal 0, so it's not a true statement. So she is not correct, since her solution only works for one equation. In order to be a solution, it has to work for both equations. For problem 659, you've decided to give your best friend a bag of red and green marbles for his birthday. Your friend likes green marbles better than red ones, so the bag has twice as many green marbles as red. The label on the bag says it contains a total of 84 marbles. So we're going to create an equation. We need to determine how many green marbles are in the bag, and we're going to write a system of equations for this problem and use any method to solve the system. So we're going to let G equal the number of green marbles and let R equal the number of red marbles. Now I could have done X and Y, but it makes sense to let G equal green marbles and R represent red marbles. So what do we know? We know that the bag has twice as many green marbles as red. So the green is twice as many as red. So it's 2 times the number of red marbles. And we know that there's a total of 84 marbles. So we know that the green plus the red equals 84 marbles. So knowing that, we can use these two equations to set up our system. We know that G equals 2R. So since both of these are not set up in G equals form, it's better to use the substitution method instead of the equal values method that we've learned so far. So if G equals 2R, we know G plus R equals 84. So what does G equal? G equals 2R. So instead of G, we're going to substitute 2R. And now we have 2R plus R equals 84. 2R plus R equals 3R. This is multiplication. Inverse property of multiplication is division. Divide both sides by 3. We're dividing this side by 3 because it creates the giant 1. 1 multiplied by R is R. 84 divided by 3 is 8. So we know R equals 28. Well, what does R represent? R is the number of red marbles. So we can plug back in to either of these equations to find out the value or how many green marbles there are. Well, the top one seems simpler than the bottom one. There's less steps, so I'm going to plug it into the top equation. And so R equals 28, and green marbles equals 2 times the number of red. Well, number of red is 28. So now we have 2 multiplied by 28, which equals 56. So we know that there are 56 green marbles. So there are 28 red marbles and 56 green marbles. Now, the last part says check to make sure your solution is correct. So we would need to plug back in our solution to both equations. And if R equals 28, 2 times R, which is 28, 2 times 28 equals 56. That's true. And we know that 56 plus 28, add those two together, we get 84. So this solution is correct because when I check my solution into both equations, they both are true.